doing well. Today we're going to look at finding inverse functions. I'm trying to color coordinate this, so my first step is in blue, and I need to use the horizontal line test to decide if f has an inverse function. So I'm going to break f down into slope-intercept form, so I will get -3/2 x plus 5/2. It just makes it a little easier to graph. My y-intercept is at 5/2 or 2.5. My slope is -3/2, so down 3/2. And we're going to do the horizontal line test on this line. So any horizontal line only hits one point on this particular line. So for that reason, I can find an inverse function. On to step number 2. In the equation for f of x, replace f of x with y. So instead of f of x equals, I have y equals the 5 minus 3x all over 2. Next step is to interchange the roles of x and y and solve for x. So instead of y equals, I have x equals, and instead of 5 minus 3x, I have 5 minus 3y all over 2. So to solve for this y, I will multiply by 2 on both sides. Now I will subtract 5 from both sides and divide by -3 on both sides. Now this has everything equal to y, and the y is on the right side of the equation. You could put the y on the left side, it's the same thing. And my next step is to replace y with f inverse of x on the new equation. So I now have f inverse of x instead of y equals 2x minus 5 all over -3. So we found the inverse function, and our very last step is to verify that f and f inverse are inverse functions. And there are a couple different ways you can do this. We can do this with domain and range, so showing that the domain of f is equal to the range of f inverse, and the range of f is equal to the domain of f inverse. There's another way to do it. You can do f of f inverse and f inverse of f to see if it equals x. Because there are so many different ways to do this, I'm going to do a different way on each problem. So in this one, I'm going to look at the domain and range. Because my original f function is a straight line, the domain is all real numbers, and the range is all real numbers of this original function. For f inverse, this actually is a straight line as well. If you rewrite your inverse in slope-intercept form, you can tell, again, this is a -2/3 x plus 5/3. So it's in slope-intercept form, it's a straight line, which means that your domain is all real numbers and the range is all real numbers. So the domain of my original function is supposed to equal the range of the inverse, which the ones I circled, those are both all real numbers, they're the same. And the range of the original is supposed to be the same as the domain of the inverse, which again is true. So we can tell that yes, we got the correct inverse function. Next one, again, we're going to do the horizontal line test to make sure that this actually has an inverse function. And if you're having a hard time graphing this, you can put it on your graphing calculator, you can put it in Desmos or GeoGebra. I'm going to show you guys on Desmos. So here on Desmos, here's our f of x equals the square root of 2x minus 3. And again, we're trying to see, does this pass the horizontal line test? Will a horizontal line ever hit more than one point? And it looks like it hits one point at most, never more than that. So for that reason, it does have an inverse function. Since we know it has an inverse function, let's go ahead and start trying to find the inverse function. We will do our next step to write y equals, instead of f of x equals, the square root of 2x minus 3. Next step is to swap the x and y. X equals, instead of y equals, square root of 2y instead of 2x minus 3. And now we have to solve for y. So I'm going to square both sides of the equation, add 3 on both sides, and divide by 2 on both sides. My next step is to write it as f inverse of x instead of the y. So my f inverse of x equals x squared plus 3 all over 2. And again, there are multiple ways to check your answer. Last time we looked at the domain and range. On this one, we are going to look at f of f inverse of x and f inverse of f of x, both of which should equal just x if we did it correctly. So I'm going to take the inverse function and substitute it into the f function. Here's my inverse function. It gets subbed into the f function. So a square root of 2 times, instead of x, I have the inverse function, minus 3. And our inverse function is x squared plus 3 all over 2. Okay, so we have 2 divided by 2. Those are gone. We have square root of x squared plus 3 minus 3. Addition and subtraction, those are inverses. Those are gone. I have the square root of x squared and a square root squared, again, inverses, they undo each other. I have just x here. Good, so my f of f inverse equals x. Now let's do f inverse of f. You have to take the entire f function and substitute it into the inverse function. So it's going backwards here. The entire f function, substitute into the inverse function. So my square root of 2x minus 3 is squared instead of x squared, plus 3, and then all over 2. Again, a square root squared, those undo each other. I have 2x minus 3 plus 3 all over 2. Addition and subtraction are inverses, those are gone. 2x divided by 2, 2 divided by 2 is 1, so we are down to a single x. Yet again, f inverse of f equals x. So this is a way for us to check and make sure we got the correct inverse, and we did. Last one here, we are looking at f of x equals x squared, and there is a bit of a restriction here. It says x has to be greater than or equal to 0. If it was just regular x squared without a restriction, I would have this parabola, and it would not pass the horizontal line test. Because they gave us this restriction, all the x's that are greater than or equal to 0, like the x's over here, are greater than or equal to 0. So I only have this part of the parabola. Now, step 1 to check the horizontal line test. Yeah, it looks like it never hits more than 1 point. So now on to the next step, we are going to replace the f of x with a y. So now it says y equals x squared, and the step after that is to swap the x and y and solve for y. So I will do a square root on both sides. Square root of x equals y. And then instead of y, I'll write f inverse of x equals the square root of x. So there's our inverse function. And the very last thing to do is to check your answer. So far, we have checked our answers by looking at domain and range and by doing f of f inverse and f inverse of f. The last thing we could do to check our answer is we could look at it graphically and see if they swapped x and y for all the points on our graph. So let's look at that. Again, you can draw it yourself. You can do this in GeoGebra or Desmos or in Graphing Calculator. We're going to look at this on GeoGebra. Okay, here are our two functions. The purple one is the original f of x function, and the orange one is the f inverse of x. They're calling it g of x. But let's see if these xy points, if they swapped the x and y on these xy points. So I'm going to look at the point 2, 1 on my original f function. And if this is correct, then it should be the point 1, 2 on the inverse function. And yeah, there it is. I'm going to pick another point, maybe 6, 3. There's a point on my original f function. And if this is the correct inverse, then I should get the point 3, 6, which, okay, yeah, the point 3, 6 is on our graph. So we can graphically tell it was a reflection over the line y equals x, or in other words, they swapped the x and y on all of our points. So we can tell that yes, this inverse function is correct. Hopefully this is helpful for you guys. Have a good day.